Welcome students. If your SAT exam is just 1 month away, don't worry. You can contact us right now through our official channels and join our intensive SAT preparation groups. I'm waiting for you, and now let's dive into the exam solutions.
Let's start with Module 1. Question number 1. Which frequency table correctly represents the data listed? Let's count. 4 appears 4 times, 8 appears 3 times, and 13 appears 2 times. Looking at our options, Table A perfectly matches this count, so A is our correct answer. Question 2. Which expression is equivalent to x squared plus 3x minus 40? To factor this quadratic expression, we need to find two numbers that satisfy two conditions. First, they must multiply to the constant term, which is negative 40. Second, they must add up to the middle coefficient, which is positive 3. Let's test negative 5 and positive 8. Negative 5 times 8 gives us negative 40, and negative 5 plus 8 gives us positive 3. This works perfectly. So, our factored form is x minus 5 and x plus 8. Looking at our choices, this matches option B, so B is the correct answer. Let's look at question 3. J walks at speed of 3 miles per hour and runs at speed of 5 miles per hour. He walks for W hours and runs for R hours, for a combined total of 14 miles. Which equation represents this situation? Before we look at the options, let's visualize what's happening. Imagine Jay's entire journey as the path. The total distance he travels by both walking and running combined is exactly 14 miles. Now, we know that distance equals speed times time. For the first part of his trip, he walks at 3 miles per hour for W hours, so his walking distance is 3W. Then he runs at 5 miles per hour for R hours, making his running distance 5R. When we add his walking distance and his running distance together, they must equal his total distance of 14 miles. So translating this directly into algebra gives us 3W plus 5R equals 14. Looking closely at our choices, this perfectly matches option A, and that's our correct answer. Let's look at question 4. We are given triangle ABC, where the measure of angle B is 52 degrees and the measure of angle C is 17 degrees. We need to find the measure of angle A. Before we check the options, let's visualize the triangle with these angles. To find the unknown angle A, we use the property that the sum of the angles in any triangle is always 180 degrees. This means angle A, angle B, and angle C must add up to 180 degrees. By substituting our known values, angle A plus 52 degrees plus 17 degrees equals 180 degrees. Combining the known angles gives us angle A plus 69 degrees equals 180 degrees. To isolate angle A, we subtract 69 degrees from both sides. Angle A equals 180 degrees minus 69 degrees, which is 111 degrees. Looking at our choices, this matches option D, so D is our correct answer. Let's look at question 5. The graph represents the total charge in dollars by an electrician for X hours of work. The electrician charges a one-time fee plus an hourly rate. Which interpretation of the slope of the graph is correct? Before looking at options, let's analyze the graph to understand what slope truly means. Slope is defined as the change in y divided by the change in x. On our graph, a change in x means adding more work hours, while the resulting change in y represents the extra charge or profit the electrician makes for those hours. Look at this visually. For every 1 hour increase on the x-axis, the total charge goes up by a constant amount on the y-axis. The ratio of extra charge per single hour is exactly what we call the hourly rate. Now, let's display our options on the right. This perfect visual translation matches option A, the electrician's hourly rate, and that is our correct answer. Let's look at question 6. This is a student-produced response question, meaning there are no multiple choice options and we need to calculate the exact value ourselves. The table summarizes the distribution of color and shape for 100 tiles of equal area. If one of these tiles is selected at random, what is the probability of selecting a red tile? Remember to express the answer as a decimal or fraction, not as a percent. Before we compute, let's visualize the formula for probability. Probability is equal to the number of successful outcomes divided by the total number of possible outcomes. To find our successful outcomes, let's look at the table and find the total number of red tiles. Looking at the red column and moving down to the total row, we see there are exactly 30 red tiles. Next, for the total possible outcomes, we look at the grand total of all tiles in the bottom right corner, which is 100. Now, substituting these values into our formula gives us 30 divided by 100. By simplifying the fraction, we can cancel out the zeros to get 3/10, or by writing it as a decimal, it equals 0.3. Both 3 by 10 or 0.3 are correct answers to grade N. Let's look at question 7. We have a total population of 50,000 people. A sample of 1,000 people is chosen at random and surveyed. Based on this sample, 35 support the legislation with a margin of error of 30%. We need to find a plausible value for the total number of supporters in the entire population. First, let's visualize what's happening. We have a massive population of 50,000 people, and instead of asking everyone, we pull a smaller sample of 1,000 individuals. Now, let's understand the margin of error. The survey says 35% supported, but because it's just a sample, the true percentage can vary up or down by 3%. This creates a confidence interval. The minimum plausible percentage is 35 minus 3, which is 32%. The maximum is 35 plus 3, which is 38%. So the true support is between 32 and 38%. To find the plausible number of people in the whole population, we calculate these percentages out of the total 50,000. The minimum number of 32% of 50,000, which equals 60,000 people. The maximum number is 38 of 50,000, which equals 90,000 people. Therefore, the actual number of supporters must be between 60,000 and 90,000. Now, let's bring up our options. Looking at our choices, option C, 60,750, is the only value that falls perfectly inside our plausible range. So C is our correct answer. Let's look at question 8. This is a student-produced response question. We are given the equation 55 over x plus 6 equals x. We need to find its positive solution. Watch closely. To eliminate the fraction, we take the denominator x plus 6 and multiply it by the right side. This transforms our equation into 55 equals x times x plus 6. Next, distributing the x into the parentheses gives us x squared plus 6x. To solve it, we must set the quadratic equation to 0. By moving 55 to the other side, its sign changes, giving us the standard quadratic equation x squared plus 6x minus 55 equals 0. Now let's factor this expression. We need two numbers that multiply to the negative 55 and add up to positive 6. Those are positive 11 and negative 5. So the equation seamlessly splits into two factors. X plus 11 times x minus 5 equals 0. This gives us two paths. Either x equals negative 11 or x equals positive 5. Since we only need the positive solution, we cross out negative 11 and our final answer is 5. But what if you didn't think of factoring? Let's clear the screen and look at a second method. The quadratic formula by identifying our coefficients where a is 1, b is 6, and c is negative 55, and plugging them into the formula, the math simplifies beautifully to give us the exact positive result. X equals 5. Grade in 5 and you are good to go. Let's look at question 9. An airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. We need to determine which type of function best models this scenario. First, the word descends tells us that the altitude is dropping over time, meaning the function must be decreasing. But how do we know if it's linear or exponential? Let's look at the visualization on our graph. As time advances by 1 minute, the airplane drops by a fixed constant amount 400 feet. Every single minute, the exact same downward step is repeated, plus 1 minute minus 400 feet. Because the rate of change is a constant amount, forming these perfectly equal steps, connecting them creates a perfect straight line. In the SAT, a constant amount of change always represents a linear function, whereas a constant percentage would represent an exponential function. Since our visual proof creates a decreasing straight line, we are looking for a decreasing linear function. This brings us to option B, and that's our correct answer. Let's tackle question 10. The question asks for the y-intercept of the graph of the given function. G of x equals 11 times 1 over 12 raised to the power of x. Before we look at choices, let's understand the core concept. What exactly is a y-intercept? Imagine the xy plane. Any point where a curve crosses the vertical y-axis is a y-intercept. Visually, this only happens at the precise moment when the horizontal position x is exactly 0. This is a fundamental rule. To find any y-intercept, x must equal 0. So, to find our specific y-intercept, we must substitute x equals 0 directly into our function. Let's perform the calculation. The function becomes g of 0 equals 11 times 1 over 12 raised to the power of 0. Now remember the laws of exponents. Any positive number raised to the power of 0 equals exactly 1. Therefore, our calculation simplifies to 11 times 1, which gives us a y value of 11. This means the exact coordinates of our y-intercept are 0 and 11. Now looking at our options, choice A matches our result perfectly, and that is our correct answer. Question 11 tells us that we have a circle with center O, a circumference of 144 pi and 2 diameters, PR and QS. Let's sketch this geometric figure with all its points to visualize the problem clearly. The most important given information here is that the length of arc PS is twice the length of arc PQ. Based on this relationship, if we visually define the smaller arc PQ as x, then arc PS is twice its size, must be 2x. Now notice that line QS is a diameter. A diameter divides the entire circle into 2 equal halves. This means that the outer semicircle made of arc PQ and arc PS represents exactly half of the total circumference. So 144 pi divided by 2 gives us 72 pi. Therefore, we can set up our algebraic equation x plus 2x equals 72 pi, which simplifies to 3x equals 72 pi. Dividing both sides by 3, we find that the value of single x is 24 pi. The question asks for the length of arc QR. If you look closely at the geometry figure, arc QR is directly opposite to arc PS because they are formed by intersecting lines. They are vertical angles, meaning arc QR is geometrically equal to arc PS. Since arc PS is equal to 2x, arc QR must also be 2x. Multiplying 2 by 24 pi gives us our final answer of 48 pi. This matches option B perfectly. Question 12 states that a rectangle has a length of x units and a width of x minus 15 units. If the area of this rectangle is 76 square units, what's the value of x? Let's sketch this rectangle to see its dimensions visually. Inside the figure, the area is equal to 76, the length is x, and the width is x minus 15. The fundamental geometric formula for the area of any rectangle is length times width equals area. By substituting our given values into this formula, we get the algebraic equation x multiplied by the quantity x minus 15 equals 76. Next, we expand the brackets to distribute x, which gives us x squared minus 15x equals 76. To set up a standard quadratic equation, we move 76 to the left side by subtracting it, resulting in x squared minus 15x minus 76 equals 0. Now we factor this quadratic equation. We are looking for two numbers that multiply to negative 76 and add up to negative 15. Those numbers are negative 19 and positive 4. So our factored form is the quantity x minus 19 times quantity x plus 4 equals 0. This yields two possible mathematical solutions for x equals 19 or x equals negative 4. However, from a geometric standpoint, a length cannot be negative. Therefore, we reject x equals negative 4 because physical dimensions must be positive. This leaves us with our only valid solution, x equals 19. Looking at our given choices, this matches option B perfectly. Question 13 presents a table showing the exponential relationship between time t in years and the total amount in dollars in Rosa's savings account. Which equation best represents the relationship between t and n? Let's read through the problem statement carefully first. Now let's bring up our data table. We can see how the total amount increases over a period of 2 years, starting from year 0. To model this growth, we use the general exponential formula for compound interest. N equals B times the quantity 1 plus R raised to the power of t. In this structure, P represents the initial amount at time t equals 0, and R represents the growth rate or interest rate. Let's look at the first row of our table, where time t equals 0. The total amount N is exactly $604. This directly tells us that our initial amount P is equal to 604. Next, we need to find our growth factor, 1 plus R. By observing the transition from year 0 to year 1, we can divide the amount in year 1, 606.42, by our initial 604. This gives us exactly 1.004. Substituting our p-value of 604 and our growth factor of 1.004 back into the general formula gives us our final equation. N equals 604 times the quantity 1 plus 0.004 raised to the power of t. Now let's evaluate our choices to see which one matches our derived formula. Looking closely at options, our equation matches option C perfectly. Therefore, C is the correct answer. Question 14 asks, at how many points do the graphs of the equations y equals x plus 20 and y equals 8x intersect in the xy plane? Let's break this down using two different methods to fully master the concept. First, let's look at method 1, the algebraic solution using substitution. In coordinate geometry, the intersection of two graphs means finding an x and y pair that satisfies both equations simultaneously. Since both equations are already solved for y, we can set them equal to each other. This gives us the equation 8x equals x plus 20. To solve for x, we subtract x from both sides, which simplifies to 7x equals 20. Dividing by 7, we find that x equals 20 over 7. Because this algebraic system yields exactly one unique solution for x, we know with certainty that there is exactly one intersection point. Now let's verify this visually with method 2 using a graphical approach, just like you would see on Desmos graphing calculator. Let's construct our xy plane on the left. First, we plot our red line representing the linear equation y equals x plus 20, which has a y-intercept at positive 20. Next, we plot our blue line representing y equals 8x, which passes directly through the origin with a much steeper slope. As we look closely at the grid, the two lines extend and crosses each other at exactly one single location in the first quadrant. This unique intersection dot corresponds precisely to our algebraic solution where x equals 20 over 7. Let's bring up our official answer choices on the right side. Since the lines intersect at only one point, the correct value is 1. This matches option B perfectly. Let's take a deep look at question 15. We are given a straightforward algebraic equation 5g plus 45r equals 380. Instead of jumping straight into heavy math, let's look at the philosophy behind this equation. The structure tells us that a certain number of green tokens combined with a certain number of red tokens yields 380 points. By reading the coefficients directly, we instantly unlock the intrinsic value of each token. Think about it. 5 times g means that every single green token you grab gives you exactly 5 points. Let's represent this visually as a green token with a core value of 5 points. On the other hand, 45 times r means that every single red token is a powerhouse giving you a massive 45 points. Let's visualize it as a red token worth 45 points. Now, the equation isn't asking us to find how many tokens there are. It simply asks how many more points is a red token worth than a green token. Looking at our visual tokens, this is a pure comparison of their face values. We take the value of the red token, which is 45, and subtract the value of green token, which is 5. 45 minus 5 gives us exactly 40. So, without solving any complex system, our conceptual grid answer is 40. Let's look at question 16. The problem states that the number of bacteria in a liquid medium doubles every single day. Starting with an initial population of 44,000, we need to choose the equation that accurately represents this relationship over t days. To see how this works, look at the data table on the left. At day 0, our population is 44,000. This corresponds perfectly to our first data point on the graph. When day 1 arrives, the population doubles to 88,000, creating our second point. By day 2, it doubles again to 176,000. Moving our point much higher, connecting these points reveals a distinct, rapidly climbing curve. This visual behavior is the exact geometric definition of exponential growth. To represent this mathematically, we use the general exponential function. Y equals a times b raised to the power of c. Here, a represents our starting value, which is 44,000. The base b represents our constant multiplier. Since the text explicitly notes that the population doubles, our base is exactly 2. Substituting these parameters gives our final customized equation. Y equals 44,000 times 2 to the power of t. Now, let's look at available options on screen. Our derived function matches option D perfectly. Therefore, D is our correct choice. Question 17 asks us to find the volume in cubic inches of a cylinder that has a diameter of 8 inches and a height of 12 inches. We have a standard cylinder with a vertical height h equals to 12 inches, and a total baseline diameter crossing through the center equals to 8 inches. Before applying our geometric formula, remember that the standard volume equation requires the radius r, rather than the complete diameter. Since the radius is simply half of the diameter, we divide 8 by 2, giving us a radius exactly 4 inches. Now let's look at the general formula used to calculate the volume of any cylinder. V equals pi times radius squared times height. Let's substitute our known dimensions directly into this structure. This gives us v equals pi times 4 squared multiplied by 12. Squaring our radius 4 times 4 gives us 16. Next, multiplying with 16 by our height of 12 results in exactly 192. So our calculated volume simplifies perfectly to 192 pi. Let's clear our workspace and pull up the official multiple choice options to find our match. Our derived result of 192 pi corresponds perfectly with option C. Therefore, C is the correct answer. Question 18 presents a system of linear equations 6x plus 7y equals 28 and 2x plus 2y equals 10. We need to find the specific value of y that satisfies this system. Let's solve it algebraically first using elimination. Look at the two equations stacked together. To isolate y directly, we can eliminate the x variables. If we multiply the entire second equation by -3, it transforms beautifully into negative 6x minus 6y equals negative 30. Now let's add this modified equation directly to our first equation. The positive 6x and negative 6x cancel each other out completely. For the y terms, 7y minus 6y leaves us with exactly 1y. On the right side, 28 combined with negative 30 results in negative 2. This immediately gives us our algebraic solution, y equals negative 2. Now, let's explore an alternative perspective using a graphing approach, just like we would analyze it visually. Let's build our coordinate plane on the left. We build the first equation, which forms our blue line, and the second equation, which forms our red line. Notice where these two lines cross. The intersection point of a linear system represents its simultaneous solution. When we look closely at the grid coordinates of this unique yellow dot, it sits precisely at x equals 7 and y equals negative 2. Since the question is specifically target the value of y, we look directly at the y coordinate of this intersection point, which confirms that y is equal to negative 2. Let's bring up our final multiple choice options across the screen. Our result matches option A perfectly. Therefore, A is the correct answer. Let's look at question 19. The problem states that in triangle JKL, the cosine of angle K is equal to 24 over 51. It also notes that angle J is a perfect right angle. We need to determine the value of the cosine of angle L. Let's break this down visually to master the trigonometry. First, let's construct our mathematical landscape on the left. We have a standard right-angled triangle named JKL, which is anchored by its 90-degree corner right at J. This allows us to focus our attention on the remaining two acute angles, K and L. We know from the question that cosine K equals 24 over 51. Based on the definition of cosine as the ratio of adjacent side to the hypotenuse, this looks in the side length on our figure. The hypotenuse stretching opposite the right angle is 51. The side directly adjacent to our angle K has a length of 24. However, notice that our final target requires information about the cosine of angle L, which involves the opposite side that we haven't identified yet. To find this unknown geometric component, we use the legendary Pythagorean theorem. 24 squared plus our missing side squared must equal 51 squared. Calculating this out gives us 576 plus our missing side squared equals 2601, which leaves us with 2025. Taking the visual square root reveals that our missing side length is exactly 45. Finally, let's turn our trigonometric focus to angle L on the other side of the triangle. The adjacent side for angle L is the side we just calculated, 45. Since our hypotenuse remains 51, the cosine of angle L is calculated simply as 45 over 51. Our visual grade answer is 45 over 51. Let's move on to question 20. Here is our function. f of x equals 4x squared minus 50x plus 126. We need to find the value of x where the function reaches its minimum. To solve this algebraically, we will use the vertex formula x equals negative b over 2a. From our equation, a is 4 and b is negative 50. Let's substitute these values. We get negative 50 divided by 2 times 4. This simplifies to 50 over 8, which gives us 6.25. This is our final grid and answer. Now let's verify this on the graph. Here is our quadratic curve. Let's track the coordinates along the path. The point moves down until it reaches the absolute lowest position. Right here at the vertex, if we look straight down to the x-axis, it hits exactly at 6.25. The result is perfectly confirmed. Let's move on to question 21. We are told that line L passes through the origin 0 and 0 and is parallel to the line represented by y equals 8x plus 2. Since parallel lines have the exact same slope, the slope of line L must also be 8. We also know that line L passes through the point 3 and D. Since we have 2 points on this line, 0 and 0 and 3 and D, we can use the slope formula. M equals y2 minus y1 over x2 minus x1. Substituting our values gives us 8 equals d minus 0 over 3 minus 0, which simplifies to 8 equals d over 3. Multiplying both sides by 3, we find that d equals 24. Looking at the graph, as we track line L from the origin with the slope of 8 moving over to an x-coordinate of 3, takes us straight up to y value of 24, perfectly confirming our answer. Let's move on to question 22. We are given the line 2y equals c, which represents a horizontal line. For this line to intersect a downward opening parabola at exactly one point, it must touch only the highest point of the curve, which is the vertex. To find the location of this vertex, we look at our parabola equation. Y equals negative 2x squared plus 9x. Algebraically, we first find the x-coordinate of the vertex using negative b over 2a, which gives us 2.25. Now, to find the corresponding y value at this peak, we substitute 2.25 back into the equation. This calculation gives us a maximum y value of 10.125. Since the original line equation is 2y equals c, we simply multiply our peak y value by 2 to solve for c. This leads us to our final grid and answer of 20.25, whether we look at it graphically or solve it algebraically. The peak is the only point that satisfies the condition. Let's begin Module 2 with question 1. We are asked to find the median of the data shown. To find the median, the values must first be arranged in order from least to greatest. Looking at our list, the numbers are already perfectly sorted for us. Now to find the exact middle value, we can simply cross out numbers from both ends, one by one. Let's cross out the lowest value, 71, and the highest value, 93. Next, we eliminate 72 from the left and 87 from the right. We continue this process by crossing out 73 and 83, and then 76 with 79. After eliminating an equal number of values from both sides, we are left with one single number directly in the center, which is 77. This middle value is our median. Looking at the choice below, this matches option B perfectly, making B the correct answer. Let's move on to question 2. We are given the equation x plus 40 equals 95. To isolate x and solve this equation quickly, we need to move positive 40 to the other side. As we shift it across the equal sign, it becomes negative 40, disappearing completely from the left side. Now, on the right side, we just compute the basic subtraction. 95 minus 40 gives us exactly 55. This leaves us with our final result, x equals 55, which is our correct grid and answer. Let's move on to question 3. We are asked to find the area of a rectangle given a length of 17 centimeters and a width of 7 centimeters. To calculate the area of any rectangle, we use the straightforward formula area equals length multiplied by width. Substituting our given dimensions into the formula, we multiply 17 by 7, which gives us an exact area of 190 square centimeters. Looking closely at our four choices, this matches option C perfectly, making C our correct answer. Let's move on to question 4. We are asked to find which expression is equivalent to 20W minus open parenthesis 4W plus 3W close parenthesis. Following the standard order of operations, we must simplify the terms inside the parentheses first. Adding 4W and 3W together gives us 7W. Now our expression becomes 20W minus 7W. Finally, subtracting 7W from 20W leaves us with exactly 13W. Looking at our choices, this matches option B perfectly, making B the correct answer. Moving on to question 5. We are given a variable statement: the number y is 84 less than the number x, and we need to choose the matching equation. Let's translate this word by word into algebra. The number y is translates directly to y equals. Then 84 less than x means we start with x and subtract 84 from it. Putting it all together, we get the equation y equals x minus 84. Looking at the choices, this corresponds perfectly to option D, which is our correct answer. Let's look at question 6. We are given that the rational expression 24 over 6x plus 42 is equivalent to 4 over x plus b, and we need to find the value of the constant b. To do this, let's simplify the first fraction by factoring out the greatest common factor from its denominator. In 6x plus 42, we can factor out as 6, rewriting it as 6 times open parenthesis x plus 7 close parenthesis. Now, dividing both numerator 24 and the denominator's factor 6 by 6, the fraction simplifies perfectly to 4 over x plus 7. Comparing this directly to 4 over x plus b, we can clearly see that b must be equal to 7. This matches option A beautifully. This is a grade and percentage problem. We are told that out of 300 seeds planted, 80% sprouted, and we need to find the total number of sprouted seeds. To find 80% of 300, we write it as the fraction 80 over 100 multiplied by 300. We can simplify this easily by cancelling out the 2 zeros in the denominator with the 2 zeros in 300. This leaves us with a straightforward multiplication 80 times 3, which gives us exactly 240. So 240 seeds sprouted, making 240 our final answer. Let's look at question 8. Ty has a daily goal to walk at least 24 kilometers. If he walks at an average speed of 4 kilometers per hour, we need to find the minimum number of hours required to reach his goal. To find the time, we simply divide the total distance by his speed. Dividing 24 by 4 gives us exactly 6 hours. Looking at the options, this matches option B perfectly, so B is our correct answer. Question 9. We are given the equation 6 plus x equals 9, and we want to find the value of the expression 18 plus 3x. First, let's isolate x in our given equation. Subtracting 6 from 9 gives us x equals 3. Now we substitute this value into our target expression. Replacing x with 3 gives us 18 plus 3 times 3, which is 18 plus 9, resulting in a final answer of 27. Now let's solve question 10. The function f is defined as f of x equals x cubed plus 9, and we need to evaluate f of 2. To find this, we substitute 2 for every x in the function. This gives us 2 cubed plus 9. Since 2 cubed is 8, we add 8 and 9 to get a final result of 17. Looking closely at our choices, this corresponds to option C. Let's look at question 11. We are given a linear cost function f of x equals 36x plus 1000, where x represents the monthly car lease payment in dollars. We need to find the total cost when the monthly payment is $400. Substituting 400 into the function, we multiply 36 by 400, which gives us 14,400. Adding the flat fee of $1,000, we get a total cost of $15,400. This matches option C beautifully. Let's look at question 12. We are given the linear function g of x equals 10x plus 8, and we need to evaluate it when x equals 8. To find g of 8, we simply substitute 8 wherever we see x in the equation. This gives us 10 times 8, which is 80, plus 8, giving us a final result of 88. Looking at our choices, this matches option D perfectly. Moving on to question 13. In the provided geometric figure, line J is parallel to line K, and they are intersected by a transversal line T. Note that the angle X and the angle 133 degrees lie directly next to each other along the straight line J. This means they form a linear pair and must add up to exactly 180 degrees. To find x, we subtract 133 from 180, which gives us an answer of 47. Let's look at question 14. We are given the equation 7x plus 2y equals negative 31. We know that the graph has a y-intercept at 0 and b, and an x-intercept at a and 0, and we want to find the value of the ratio b over a. First, let's focus on the y-intercept to find our value b. To do this, we set x equal to 0 on the left side. This simplifies our equation to 2y equals negative 31, which means b is equal to negative 31 over 2. Now we have b. Let's move to the right side and find the x-intercept value, a. Here we set y equal to 0. This simplifies the equation to 7x equals negative 31, giving us a equals negative 31 over 7. To find the requested fraction b over a, we divide negative 31 over 2 by 31 over 7. By multiplying by the reciprocal, the 31s cancel out completely, leaving us with a positive fraction 7 over 2. This corresponds exactly to option D. In question 15, an object travels at a constant speed of 12 centimeters per second. We want to find the time it takes to travel a total distance of 180 centimeters. Since time equals distance divided by speed, we simply divide 108 by 12, which gives us exactly 9 seconds. Moving on to question 16, John paid a total of $165 for a microscope. He made a down payment of $37 and the rest was paid in monthly installments of $16 each. To build this equation, we multiply the monthly cost by the number of months, which is 16 times b, and then we add the initial down payment of 37. This total must equal 165, which gives us the equation 16p plus 37 equals 165. Let's look at question 17. We are given a table representing a linear relationship and we need to find its equation. First, let's look at the table when x equals 0. We can see that y is 18, which immediately tells us that our y-intercept, our constant term, is positive 18. Next, let's determine the slope by looking at how y changes as x increases by 1. As x goes from 0 to 1, y drops from 18 to 13, which is a decrease of 5. This means our slope is negative 5. Putting it all together into our slope-intercept form gives us y equals negative 5x plus 18. In question 18, we have an object kicked from a platform. The height is given by the quadratic function h equals negative 4.9 t squared plus 7t plus 9. The question asks for the height from which the object was kicked. This means we need to find the initial height. The initial height always occurs at the very beginning, which means at time t equals 0 seconds. If we substitute t equals 0 into our equation, both t squared and t terms become 0, leaving us with just the constant term, which is 9. Therefore, the initial height is 9 meters and the correct option is D. Now let's look at question 19. We are given the function h of x equals x squared minus 3. We need to find which of the 4 tables correctly represents 3 values of x and their corresponding outputs. Let's test the values one by one. For x equals 1, h of 1 equals 1 squared minus 3, which gives us negative 2. For x equals 2, h of 2 equals 2 squared minus 3, which simplifies to 4 minus 3, giving us 1. And for x equals 3, h of 3 equals 3 squared minus 3, which simplifies to 9 minus 3, giving us 6. Now looking at the 4 tables on the screen, let's log for the outputs, negative 2, 1, and 6. As we can see, the only table that matches our calculations perfectly is table B. So B is our correct answer. In question 20, we are given a linear function f with 2 known points. F of 0 equals 8 and f of 1 equals 12. We need to find the equation that defines f. Any linear function can be written in the form f of x equals mx plus b, where m is the slope and b is the y-intercept. Since f of 0 equals 8, this immediately tells us that the y-intercept b is equal to 8. Next, we use f of 1 equals 12 to find the slope. Substituting x equals 1 and b equals 8 into the equation gives us m plus 8 equals 12, which simplifies to a slope m of 4. Putting it all together, our equation is f of x equals 4x plus 8. Looking at our choices, this matches option D. Moving on to question 21. We are given the equation 14j plus 5k equals m. The problem asks us to solve for k in terms of j and m. To isolate k, our first step is to subtract 14j from both sides of the equation. This gives us 5k equals m minus 14j. Finally, to get k completely by itself, we divide the entire right side by 5. This results in k equals m minus 14j divided by 5. Checking our choices on the screen, this algebraic expression corresponds perfectly to option A. Now let's look at question 22. We are given the side lengths of a right triangle RST, where side RS is 440, side ST is 384, and the hypotenuse TR is 584. We are told that triangle RST is similar to triangle UVW, where vertex S corresponds to V, meaning both are the 90-degree right angles. Vertex T corresponds to vertex W, and we need to find the value of tan W. Because the two triangles are similar, their corresponding angles are perfectly equal. This means that angle W is equal to angle T, so tan W is identical to tan T. Looking at our first right triangle, the tangent of angle T is defined as the length of the opposite side divided by the adjacent side. The side opposite to angle T is RS, and the side adjacent to it is ST. Therefore, tan T equals RS over ST. Substituting our given values from the diagram, we get 440 over 384. When we simplify this fraction, we get 55 over 48. Therefore, tan W is equal to 55 over 48, which makes D our correct answer. And that's the full exam solved. Subscribe so you don't miss the next episodes. And if you are serious about your SAT preparation, check the SAT math course details in the description. Message me on WhatsApp if you have got questions. Thanks for watching.